Okay, welcome to the IEEE Greater Body meeting for today, 426. And this one's on my infatuation, and the hobby of mechanical keyboards. So, hope everyone enjoys. And so I guess we'll start with the anatomy. What exactly makes up a mechanical keyboard? Uh, I think a lot of people take them for granted in the fact that they're just used for tools, but there's in fact a very large hobby of underground people that enjoy mechanical keyboards. I'm one of them. And so to start, we have some required and optional things. First is required is case. Case is going to hold your internals. It's what you're going to pick up, you're going to grab, you're going to move. And then we have our PCB. This is your interface between the computer and your input devices, being the switches. And so this is where your it's going to sit inside of your case and protect your delicate internals. A plate is going to be the next big thing. It's going to be sitting above your PCB, but it's going to also have what your switches sit in. Stabilizers are going to be your next required thing, and they're going to need to be used on keys that are longer than 2 units, where a unit is the size of a single switch or a single alpha key. So your A key will be a 1 unit long key versus your backspace, your shift, your enter, and your spacebar are going to be longer than a single, or going to be longer than 2 units, and therefore will require stabilizers so they do not fall off. And then switches. Switches are going to be your actuation device. They're going to be how you interface with your computer, and so they're going to be required to for your keyboard. And finally, something else that's required are your keycaps. It's what you interact with. These are what you press, and they can be made of multiple different materials. You also have some optional things that will certainly affect the feel and the look. You can use lubricant, and that's going to be used to reduce friction between your switches and perhaps your stabilizers as well. You also have what are called switch films, and films are going to impact your feel and sound of your switches, and these are all augments that are not required, but certainly are nice to have. And finally, you have case foam. Uh, Obviously, having different amounts of empty space in your keyboard are going to impact the sound and the output. And so case foam is often desirable as people prefer a more muted sound, as the foam will soak up a lot of the noise. So starting with this, switches are going to be probably one of the most important choices, as they are going to impact exactly what typing on your keyboard feels like. And so the most popular are going to be the Cherry MX style. Now, everyone's probably heard of Cherry, or some people have heard of Cherry if you've used mechanical keyboards before. And they had a patent on the MX style switch. They did, in fact, not they were not able to renew that patent, and so other manufacturers have come out and make variations on this MX style switch. And this makes up 5 pieces to the switch. You have the top housing, the bottom housing, the spring, you have a leaf, and then you have a stem. And all 5 of those are going to make up the actuation device. Um, there's also another form factor called the Kale box style switch, and obviously there's many, many more switches, but these are the 2 most prevalent nowadays. And so taking a look at a cherry style switch, if you see, here's your bottom housing, and inside that bottom housing will be your leaf. This is your contact. You have a spring, you have a stem, and you have a top housing. And so this stem will ride on these rails in this bottom housing, and these legs here on this switch will push in this contact and cause an actuation. And in order for this to return and to make another actuation, the spring will return the stem back up, and it will hit and rest on this top housing. Now, the Kale box style does it a tad bit differently. It still has the same components, but the contact is going to be a little different. Instead of this being a leaf like so, it's actually hidden in this white compartment right here. And there is a little contact, which is this green guy right here, which the stem will have a little piece of plastic that will press that contact on each of the different actuations. So taking a look at that contact, we have very similar leaf design, not in the sense that it's it looks exactly like one of the cherry stems, but in the fact that it still is a push style contact that will cause an actuation. Moving on to the types. So these are going to be your variations on the cherry and the box style. And so they generally come in three flavors. You're going to have your linear switch, and it's going to be an uninterrupted, no resistance, full through. When you press a switch, it goes all the way down, and it's the same all the way through. And those are generally called linears for their linear feel and linear actuation. Tactiles are going to give you some sorts of feedback. They're going to be a bump or a break that will not cause a smooth transaction between an up and a down. And so this is good for people who desire a feedback or knowledge that they have since pressed that key. And then clickies are for a specific type of person that enjoys both a tactile bump and an audible click afterwards. So looking at a stem for a linear switch, you will see that it is a flat surface on what we call the legs. And so these legs are flat, and this is what's going to generally give you the feel of a linear switch, one that is flat and uninterrupted. Now on the left here, you'll see that they have these little white nubs on the bottoms of the what we call these rails. And these nubs are going to soften the impact and make them silent. So you have both a linear silent and a linear non-silent version of the switch. Much like the linears, you also have what are called tactile stems. And so these stems are going to have bumps or round corners to the stem legs. And so looking at this flat portion compared to this bumpy portion, you can see where that becomes a break or a bump. And so when people describe tactiles as a bump, they give feedback. It's because it's it's a interrupted version of a key press. Just like the linear stems, there's also a piece of silicone that can be used as a dampener to make them a silent variant. Finally, you have the clickies. So this is a clicky stem, in which case it is a two-piece part. This is what we call a click jacket, in where pressing down will cause the stroke upwards to return in two pieces, meaning this blue piece will hit the top of the top housing before this bottom piece does. And so it'll cause a feedback return in two pieces, in where this white piece will cause that audible click that comes from a clicky switch. There's also, however, another variant, and so you've seen this picture before. Now we are going to show this is how the Kale box style have decided to implement their click, and that is with a click bar. So this little piece right here is a piece of plastic off of the stem, which will push up and down this bar. And so depending on the size of the bar, that will determine the noise and how heavy it is for you to click past this bar. So people will debate on which version of this is better or worse, and it really comes down to preference. So now we know what the switches are. Well, you talked about lube the other time. So how are we lubricating these switches? Well, generally lubrication and the switch film will come hand in hand. So lubrication is obviously going to reduce friction. The whole point of this is to make it as smooth as possible. And so this contact between the stem rail and the slider column in the switch housing, the goal is to make that as little as possible. This is generally very much true on linear switches. So on a linear, you don't only have contact between the rail and the housing, you also have it between the stem legs and the leaf. And I'll show you what I mean by that in a minute. The reason why we do not lube the legs on anything but a linear is because a tactile wants an audible or an inaudible bump, and the whole point of keeping that free of lube is so that we maintain that tactile feedback. As soon as you put lubrication on it, it loses a lot of that feedback. Some popular ones include Krytox and Trebosis, and these two are going to give you a wide range between some very viscous lubes and some very thin lubes. Viscous are generally preferred for a lot of the linears because that's going to give you more of a greased layer between the plastics. But obviously too much and it's not going to be the feel you're looking for. So it's a less is more approach. And then the thinner lubes for something like a tactile so that there's still that feedback that you receive, but not in the way that it's too much that it gets, there's too much lube. So obviously less is more. That's kind of the general mantra. And then filming is going to be a addition to this, in which the goal is to put a piece of plastic in between the top and bottom housings to reduce rattle. So poor tolerances in some of these switches will result in the top and bottom housings rattling, and that may give you an undesirable sound. And so in order to do that, you place that piece of plastic between the two, and it will tighten it up. And it also has a benefit to sound in that a tighter switch is often a deeper sounding switch, kind of described as a thock by some of the community members. And so here we can see exactly what I mean by that. So in lubrication, you have the rails on the side of the housing, and then the rails on the side of the switch. And those are your main big touch points. So having those lubed is better. Now, these legs here are also going to touch the stem, or the stem legs are going to touch the leaf. And so that's where the tactile feedback comes from if it is a tactile switch. And so you want to avoid lubing that if it is one, if you want to maintain that feel. But linears, as they do not have any such feedback, it's often generally regarded as okay and certainly preferred if you do lube those legs. And filming is pretty self-explanatory. A piece of plastic between the two contacts will give you the best fit and finish between your switch. Moving on to stabilizers. Stabilizers are, again, pieces of plastic that will allow your switch to return on switches that are 2 units long. And so these are for your modifier keys, your shifts, your enters, your spaces, your left shifts, your deletes, generally those keys. These are also commonly lubricated because this is the sticking point on many pre-built keyboards is the fact that their stabilizers are often rattly. And so you'll hear it. It has a very distinct sound to most of the pre-built mechanical keyboards. So these are also commonly lubricated, and they're the biggest source of noise. So generally there are two sizes for space bars, and so your stabilizers are going to give you the size of what spacebar you're going to use. So the two general sizes are the 6.25 units. That means it is 6 units and then another quarter long, or 7 units. Generally, in the older keyboards, you will see that they did not actually have system keys. So there was no Windows key on a lot of these older keyboards, and this is only a recent addition. So 7 units used to be a default length, and now we hardly see it. And then you have two types of your stabilizers. You'll have a plate mount or a PCB mount or screw-in. And so this determines where that stabilizer will mount to. And so PCB mounts are going to mount in just your, they're going to mount on your plate as well as on your PCB. So these two level of mounts are going to give you a better sound profile. It's going to keep them stabilized better. They're not going to rattle and move around as much. And is generally considered the superior mount. So taking a look, this is a stabilizer for a 2-unit key. You'll have a inner and an outer housing. And so you would generally lubricate the plastic on plastic contacts before inserting them. And then you would lubricate what we call the stab wire. And so the wire is going to allow your switch to go up and down and return with your switch. And so on a keyboard, it'll look very similar to this, in where your switch, will sit in the middle, and your longer keycap will fit onto all three of the stems, and that will allow it to return at the same time. So plate materials. This is going to be the most dominant effect on what your keyboard feels like, because you'll see later that the material choice that you use will give you the entirety of what your keyboard will feel like. Starting with the metals, some popular metal plates will include something like a brass, which is very stiff, stainless steel, also very stiff, and aluminum. The aluminum is going to have a little bit more flex than the other two metals, but it's also going to determine your sound as well. So something like a brass will get a little pingy, and a stainless steel will be very muted, and it just depends on the metal and what properties that it gives. Aluminum is generally the all-arounder. You'll find that on a lot of mid to high-end pre-builts as well as entry-level custom keyboards. And is generally considered like an all-arounder board. It fits many profiles. It does very well with all types of switches. Moving on to the more exotic materials, we have an FR4 or a carbon fiber. These are your stiff non-metals. Yeah, and you'll see that these will give you a more bouncy feeling without being a very stiff experience. And then we have the plastics. So a polycarbonate is going to be a very flexy piece. You can wave it in your hand, you'll see it, it'll flex all the way around. Moving on to a POM, this is a more softer plastic, but still quite flexible. And then a polypropylene, which is, you can bend this around, move it all around, very, very, very flexible. And generally, it's considered in this hobby that a flexible a flexible plate and a flexible board will give you, is generally more desirable because of the fact that many pre-built, many entry-level customs do not give you the option to have this flexible feeling when typing. So PCBs, the next part. You will generally get this when you order a keyboard. A lot of the pre-builts come all assembled. However, you may need to source a PCB for a case that you're buying. Generally, this is only the case with keyboards that have a universal layout, as we'll see later. But this is where your switches will contact, and this is how you're going to interface with your computer. You're going to need one of these, or you will have to hardwire it. But that's a topic for a different discussion. So you're going to need to do one of two things. You're going to either solder these switches, or you will need a socket that you can insert your switch into. And that socket is soldered onto the back of the board anyway. So some amount of soldering will be required. There are generally going to be 1 to 3 mounting locations. Switches either come in a plate or a PCB mount variety, meaning they have 3 or 5 pins. And so 2 of those pins are for contact, and the other two pins may be for straightening or inserting into the PCB. And the PCB is going to determine the layout. You may have heard of 10 keyless, full size, or 65% or 60%. These are the layouts. And so in order for your board to be that, you have to have that amount of switches available to be mounted onto that board. And so then you also have a little more interesting things like split keys. The keyboard that you may be sitting in front of does not have to look like that all the time. A common practice is called split backspace, in which your backspace key is split up into 2 separate keys. And so one could be your typical backspace key, and one could be an insert, or it could be a print screen. And so on smaller keyboards, it's generally regarded as an okay practice to split a lot of these longer keys that have modifiers on them. And so this will all determine your spacebar length. If you want to go for a 6.25 or a 7-unit one, you need to make sure that PCB actually supports it. And finally, it'll determine the layout. So in the United States, we commonly see ANSI here, which is our general long enter key. However, in Europe, you'll also see what's called ISO, in which case you have a 2-row long enter key. And so it changes up how the PCB will need to be designed in order to use it. And so this is the PCB for my keyboard. As you can see, there are two mounting spots for the stabilizers on this board. So I can run a 6.25 or a 7-unit long one. Here again, we can see there's 3 switch openings as well as stabilizer holes for a split backspace. So I could run one or the other. This is a bit more of a higher end board. This is for a key cult, one of the very desirable boards in the hobby. And this comes with what's called a daughter board. And so a daughter board allows you to move your connection between the PCB and the power port. And so here it allows it to connect it with a small cable, but this allows one main advantage. You no longer have the Type-C port, or in whatever case you use, on the board. And so this allows for a mix-up in mounting styles. And so mounting can change because you no longer have a cutout that must be maintained in order for the PCB to move. So if you wanted to have a flexible board, you would want a daughter board so that you can move that that cutout to be with a daughter board as opposed to on the board. Because if you flex that board too much, you can risk it cracking, or if it's stuck inside of a cutout, like on the back of your board, there's another issue because many of these, generally all of them, are detachable cables. So moving on to cases. Cases generally require a custom designer and a manufacturer to facilitate the purchase. Um, Many of these are very low volume, low interest, uh, what we call group buy runs. And what that means is you do not have any in-stock boards generally. When you have low volume, it's very expensive to get things manufactured to be in stock. And so the best way to run this to keep prices down is by a group buy. And that means a vendor will come out with an idea and say, hey, we want to run this. They'll gauge community interest. And if it is with enough interest, they will run for about a month where you can purchase this keyboard. However, you will not get it for another couple of months because in order to have this manufactured, the manufacturer wants all the money up front. So you will put into a pool. That pool of money will be delivered to the manufacturer, and then the manufacturing process will start. So it generally is a couple month process, sometimes longer. It depends on which manufacturer you're going for. And again, cases along with PCB are going to determine the mounting style. If you do not design a keyboard to have a certain mounting style, it will not have that mounting style because there is going to be machining that involved in making that. And it generally will come with its own PCB as stated previously. And those PCBs are generally specific to the case. If it has a unique mounting style, there's very, very, very few that will have intercompatibility with other cases. And if it does not come with a PCB, then it will follow a standard sizing. So generally it's accepted that most tray mount boards are going to have a universal PCB that will fit with a lot of the other tray mount cases. However, that is not always guaranteed. And the cases can determine the form factor. So how big of a board do you want? Do you need arrow keys? Do you need any of your number pad on the right? Do you need any of your special arrows? Do you need the function row? And that'll determine what you want. So a 60% is just going to be your alphanumerics as well as your modifier keys. A 65% will allow you a couple special keys like your page up, your page down, your end, as well as your navigation cluster. You're going to have your arrows. 75 adds what 65% has, plus you have your function keys back. 80% will be a removal of the number pad, and then 100% is going to be your full size with your number pad. And so this is an example of a custom. This is called the AIO3 Vega. And so the Vega actually just won the Keyboard of the Year for 2020. It did really, really well at a great price point and includes a lot of features like what we call a gasket mount. It's a very popular board among newer enthusiasts. And then here's something like a kind of like the old classic. This is the TGR Jane V2. This currently goes for $6,500 on the used market. And this is an example of supply and demand. They only made about 150 of these boards. And so the community really, really enjoys them. And so they have become very, very valuable because, again, on a group buy basis, no one is making this board anymore. And so as demand rises, the price will as well. Moving on to mounting mechanisms. This is not going to be as important as a plate material choice because the plate material may counteract and block out everything that you've gone for on a mounting mechanism. However, they certainly are important. Some common mounting mechanisms can include tray mount, and I've said this many times so far, which is where you'll find this on really entry-level customs because the machining is super easy. It's basically a tray, and then you sit all of your internals inside of it, and you screw it to the bottom. You have a top and bottom mount, and this will break up the machining, so it gets a little bit more expensive, and you'll find these on more mid entry-level customs. Gasket's relatively new, and it's starting to come out a lot more on some very entry-level boards, and we'll go over what all these mean in the next slide. You have an integrated plate, and you'll see that again on entry-level customs or pre-builts. Some uncommon ones, these are the really interesting ones that you don't often see. You have something like a pin mount. You'll see something like a plateless, meaning there's actually no plate, or something like a leaf spring, which uses some shims and foam pads that will move up and down depending on your pressure. So here's a good cheat sheet for all of this. A tray mount looks very similar. It's a giant tray, plate PCB go in, and they screw to the bottom. Generally, this is seen as an easier manufacturing thing. However, there are general disadvantages to each and every one of these. Tray mount's advantage is the fact that it creates hard points. So while typing, you will see and you will feel and you will hear all of these sounds that will come when you type near a mounting point. And so that's considered a hard point. Now, as I was saying before, the plate generally is going to override a lot of what makes you choose your mounting style. If you use a metal plate, you generally won't notice the difference in a lot of these mounting mechanisms as there's super minute changes. They won't actually affect it in a big way if you are not using, say, a plastic plate. So moving over to top mount, the top mount means the plate is screwed into the top portion of the case, where the case is actually in two pieces and not one. So as you can see here, you have the screw that screws the plate and then connects the case in two pieces. This is what's called a hard mounting style, and it will require a separate plate, meaning it doesn't work for everything. It depends on the implementation of the case. So in that way, it's a better mount. However, it's more expensive in the long run as you will need to manufacture differently and come up with a custom solution for the plate. Bottom mount's much the same, except you flip it around. It screws to the bottom, and then the case come together. Something like a plateless mount is very interesting in that there is no plate, and you're literally using the PCB as the flex point. So I think people generally have an idea that PCBs should be treated carefully. However, they are a lot more rigid and a lot more durable than I think people give them credit for. And they can be used to give a very flexible style. That's not to be said that you can do just about anything with PCBs. They are still fragile, but they can take a lot more abuse than I think people know. And this is probably about the ultimate flex, is not having a plate. Plates will give you they will stiffen up the feel regardless of what you use. So it really depends on what style of, what type of typing experience are you looking for. Looking at the integrated plate, that means the top and the bottom or the top frame and the plate are the exact same piece. and then they mount together. And this will often give you a really stiff feel because there is there's no bounce, there is no movement, there's no deformation of that top frame because they're separate together. Um, and obviously the new kid on the block, this gasket mount, has become really popular as of late, kind of like the trend of 2021, where you have a piece or a material, something like a poron or your silicone, which will dampen and cushion all of the up and down strokes of the plate onto the case. So it's actually not screwed in, but friction fit. So it allows you movement in the up and down direction because of the fact that your material, your gasket material, is being cushioned up and down. So it's a nice a softer feel. But as I mentioned before, if you use this mount style with a metal plate, you typically don't get the same feel as if you would with a plastic plate. So the plate and mounting style are always going to be a separate discussion. What is worth going with what? And so finally, to wrap it up, you're going to need keycaps. And so your keycaps are going to come in three main material choices. You're going to have ABS plastic, you're going to have PBT plastic, and you're going to have POM. And so there's going to be disadvantages and advantages to each style. But generally, each one is going to feel fine on its own. It's going to mainly depend on the manufacturer. And so whoever manufactures this is going to depend on what style of manufacturing they do. So in the community, GMK double shot is by far and away the most highest of quality. And a double shot keycap is going to have two pieces of plastic form a single mold, and that's going to give you the crispest legends and going to be the most resistant to wear. And then you'll have something like a dye sublimation, which you're basically melting a legend onto your keycap. And so EPBT and Geekarc are some of the manufacturers for these. And then finally, you're going to have a profile. And so the profile is going to determine how these keys look and feel. And so Cherry has been by far the most dominant. I think if you look down your keyboard, you will likely see a Cherry profile keycap, and I'll show you a picture of that in a moment. SA is going to be your sculpted one, and so this is going to be a larger, more high-profile version of Cherry, and Kaz is going to be like a mix of the two. Granted, there's a lot more profiles in these, but these are some of the common ones. And so taking a look at the manufacturing again, taking a look at the top left, you're going to see something like a pad process or a sticker, in which case, if you look down, you may see some wear on a sticker on your keyboard. And this wear is determined by the fact that you're going to rub off a sticker eventually. Something like the top left and the or top right and bottom left, you'll see something more like a dye sublimation where it's been melted on, and so it's a lot harder to wear the legends off. Whereas on the bottom right, you'll see what's called a double shot system, in which case it is two pieces of plastic that mold into one, where the bottom layer is going to be your legend, and the top layer is going to be the surrounding plastic. So generally, it's determined that double shot is the higher quality of the processes. And then here you are. These are your keycap profiles. And so the profile is going to determine what it feels like when you're typing. If you like big separation between the keys and you need to feel like a almost bowl-like sensation in the keys, you may be looking at an SA profile. And if you look at this guy, he's generally almost double the size of a Cherry key. So this is going to be a giant determinant in what you enjoy. And as you get to a different section of the hobby, you may see what we call ortholinears, and that means there is zero sculpt to the keys. They don't move in determining to which row you're at. Row 1 being your number row, and then row 4 being the one right above of your spacebar. It'll all determine what you feel like doing. So that's the end of mechanical keyboards. If you have any questions, let me know. I'll be here. Happy to take them.
I'm gonna be so conscious of how my keyboard feels in every aspect now. It's gonna drive me crazy.
That is one or one critique of the hobby is that we are all insanely detail oriented and very much appreciate the small things. So it really depends on what you value. Keyboard generally is a tool, and if you see it as such, great. If you see it as I don't want to say an art piece, but it very well could be looked at as such.
So what's your keyboard of choice?
So I don't actually just have one. I have six. Uh, however, right now, as I showed you prior, I'm using a KBD 8X Mark II. So let me try and find that. So that's my PCB, and I use what's called a brass plate with tactiles. So right now, I prefer really stiff and really pronunciated tactile feedback, and so that's what I look for in a keyboard. How big can I get the bump before it's too taxing to write on? I really enjoy very pronounced keys with a very stiff feel.
A general question about the keyboard lubricants. You were talking about a few of like the named brand ones.
Sure, yeah.
If I just happen to have a brand of like Home Depot generic plastic lubricant, is that gonna be the same thing?
So generally, when we recommend lubricants, it's because they've been tried and tested with the certain plastic materials we use. So switches will come in very, very different materials. You can have nylon, polycarbonate, a mix of the two. And so when we recommend these lubricants, it's because we know that they won't rot or go through or have adverse reactions with the keys. Um, Generally, I would recommend against using whatever lubricant you may have from Home Depot. Um, However, can't stop you, and you can go for it. You can try it. Try it with
I
one
mean,
switch and see.
because my sort of thing is like I am genuinely literally holding a bottle. And I'm trying to figure out like I do have a sticky key, and I'm wondering if this is the right thing.
Uh, um,
If it's petroleum based, though, I
Uh,
don't know if you're gonna want
no,
to
no,
do
no.
that.
It's a dry plastic silicone lubricant.
hmm.
It's not. I've tried that. It's. I think it's just that it's the control key, and I think I've just worn the spring down a little bit.
Right, yeah. I would recommend against it though, Matt.
But
Typically
it's
we use
got
these
some
because
good
they're tried
warning
and true.
labels.
I know it's very common when lubing stabilizers that people will use Permatex, which is the basically a grease, and it does eat away at the plastic over time. Maybe not something that's noticeable in a period of 2 years or so, but after that, you will have rot of some of your plastics. So that is something to note.
Uh, so if we were talking like just sort of recognizing keyboards in the wild,
Mhm.
you walk into someone, you're wondering what keyboard it is.
Sure.
Even if we're just talking like generic computer center, how do you tell the difference between like a mechanical keyboard and like, a nicer membrane keyboard?
So membrane keyboards are going to have a totally different type and feel in that some of them are going to use rubber domes. And so I think if you're a little bit more in the scene, you may have heard of Topra. And so Topra generally has a sound and a feel that is very similar to a lighter tactile switch, but it's going to use and feel a lot different. One surefire way is to take a keycap off. Once you can see that it is not of the cherry kale variety, you're likely looking at something that is not a mechanical keyboard. However, there are some very old school switches, something like an Alp switch or a Cherry MY switch, that are going to give you very similar feel to something like a cherry switch. However, it's going to be a bit older, so they've kind of fallen out of favor, and not many people have heard or seen them.
I'm just realizing I have a lot of old esoteric ones, and I have no clue what they are.
Well, if you want to, you can take off a keycap, send me a picture. I may be able to
Yes,
figure out what it is.
no, they're old Apple stuff, and it's like there's no way I'm getting that off without breaking it.
Okay.
Like it's not. I don't mean. I mean the old like Apple II keyboard.
Oh, so generally in that era, you're looking at a buckling spring, which is where you would collapse the spring in the center, and it would rebound from there. And so this is generally considered one of the most tactile switches because of its just pure mechanical ability to create a giant force back, like a feedback. But I do remember Cherry and Apple did create um, a keyboard. I'm not sure around what era, but I don't know, you may have gotten lucky. A lot of the older Cherry switches that have been used for a long time are labeled as vintage, and so they've had a lot of use and are of the old tooling variety, and are generally considered a lot more superior than the newer ones.
And so let's say I wanted to do a custom board, like one-off. What are the options if, because you're talking about, group buy or something. Let's say I
Right.
don't want to do that. I want to do a one-off. What's the
So,
realistic options?
so a one-off, you'll have to go to a manufacturer specifically, and you as a consumer probably won't be able to do that. But there are companies, for example, Keycolt was one of the ones. They will have an option to work with some of the manufacturers, or they themselves, if they have their own manufacturing plant, to do a one-off. And so you would go back and forth on the design, what you want from them, um, or what you want out of it, type of mounting style, your plate material, everything. They are just generally very, very expensive.
And is software kind of standardized for this? Because, if we're making USB keyboards versus PS2 or something, I imagine there's differences.
So generally, they all use an Atmel controller. They're all programmed in AVR, and depending on which firmware you load with it, you'll have a couple of software choices. Because generally all these PCBs, you can remap any of these keys. You can add layers. You have macros available. And it really depends on who makes your PCB. But it's generally around 80 to 85% of the boards now use what's called QMK. And the QMK software has been since ported to another program called VIA, which is a much more less obtuse version of QMK. And depending on the firmware, you can see yourself in VIA or QMK.
Interesting.
All right, that was a longer one, guys, but I hope you enjoyed it. Everything else, here, feel free to message me. I don't bite. But if you have any more questions, I guess that concludes our GBM. Thanks for coming.